Alright, another draft physics presentation. Okay, on the same crappy subjects, and look, there's 5 moving elements or whatever, so you got to keep your eye on the ball kind of thing. And as I pointed out, I don't think this is a relevant subject in the sense that I think we've already established that the pattern isn't created by this mechanism. It's created by the beam splitter, and this experiment can't take place in any kind of rational manner at any speed moving the device because it changes too many variables. All right, so we're arguing an animation where we're not obligated to pay any attention to any consistent rules. Like rules like if the basketball hoop is moving and I'm going to throw a basketball into it, that I have to time exactly the movement of the basketball hoop in my throwing of the basketball. I have to essentially throw it to a future location, one future location. Not any future location, not numerous future locations, but one specific future location. Alright, so to the animated GIF guy. So I've already gone through my point, which is that if you actually did this experiment at very high speeds, or whatever, half the speed of light, that what would happen is that your photon would never hit the mirror. The mirror would move this way, the photon would go this way, it would never hit it. And if I made some sort of, infinite mirror, so it was guaranteed to hit a mirror, it would never go back to the beam splitter because the beam splitter would go this way, and then it would go this way some more, and the photon would go back this way. The photon would always be on the same line of its emission, and it wouldn't change any. And the only way you could get it to go somewhere else is you have to change the angle of the mirror. And if you change the angle of the mirror, then you could shoot the photon into some future location. And maybe it would hit the beam splitter, let's say. But then the problem is we have another thing, the target, and it would miss the target. The beam splitter has no reason to bend it this way, so it wouldn't get to the eye that was supposed to receive it. So you have to focus again to hit some other location where somehow you can put the beam splitter and the eye somehow line up, which I don't think there's any angle where that's going to happen, because obviously you can't change the fact that they're in line with each other. The mirror, the beam splitter, and the eye are all in the same alignment. And there's just no angle. You can't go like this and bounce off nothing to get here, and then if you get here, you're still not in here. So that's not going to be any good. I mean, as a practical matter, this and the moving mirror, you're already the experiment's already impossible. There's no scenario here. So I've attempted to argue that the animation has contrivances in it. And so one of the contrivances is that we can sort of understand that if we go straight up and straight down, okay, that's the fastest to go from here, point A to point B, is in this straight line. So again, now if we're going to project where the mirror is going to be into some future location, so we're going to change this line, and the idea would be is technically that we're going to do some sort of equal angle thing, okay? But then we kind of know that the same amount of time is going to get us short. And that also goes for hitting the mirror itself. And so there is a location out here where if you go that location, you'll hit the mirror and you'll end up, at some future location. But the beam splitter won't be there. So you'll hit a place that the beam splitter won't be. And we sort of went over this, that if if this line is going this way and reflecting off a mirror at that same location and comes back, that it will be at the beam splitter. But you can't have both things at the beam splitter at the same time. These two dots technically can never line up, because as I change this angle, what I'll end up doing is changing how far that goes. And so these dots would go something like this. So their arc is out of phase, so to speak, with being in alignment. So this ball would always be on this path. So it's always on a line here. And there's just the only place you can't have them line up, especially once this one goes the opposite direction. It's just not possible. The only way you could have them line up is have this one continue to go this way, and at some location out here you might have the two of them hit each other. But then you got a problem where you can't hit the mirror. So there's no way you can line up the mirror, the beam splitter, the eye, and have the two balls ever in the same position. So they'll never travel the same distance. But they'll also you'll never be able to receive them with the experiment either. You won't see them. The ball will go this way, or if it goes through the splitter, or in most cases it'll go too far. And that's all you have. There's no way to make this thing work as a mechanism to have any kind of consistency. So again, especially without changing the angle of the reflection. So in the real world, in slower speeds, you change this angle and you can get away with it, because although the alignment won't be perfect, you'll hit some part of the beam splitter, and then you have some part of the eye, and by changing that angle you can make it hit some part of it. But that was the problem Michelson Morley had, is they rotated this machine, they didn't, whatever, and they pointed out that they had to keep readjusting this focus. So they had to keep readjusting it, because yes, they kept changing the position of the eye, the alignment of the beam splitter, where they could possibly hit some portion of it. They could never go through the middle of anything. They couldn't hit the middle of this mirror, the middle of the beam splitter, and the middle of the eye. You can only do that here. So what's happening in the animation and makes this whole thing moot, especially, is this angle of where you decide how. So I've granted them the right to propose this idea that photons move forward, as long as they account for the fact that this distance is longer to travel. So we're ignoring that photons really go this way, and we're saying it's okay to have them go this lighthouse effect. But the trick is this angle, what you do to this angle is arbitrary. I mean, you can go at, if you want to, you could make any angle. But if you're going to be consistent to the experiment, you'd have to go the angle proportional to your speed. So if you were going half the speed of light, this angle would have to be 45 degrees to be fair. It would have to be half the distance to represent that you're going half the speed of light. At going the speed of light, you would be going a straight line with the direction of the light speed, the direction of the motion, and at zero change, you'd be going zero angle. So that adds up. So 45 would be the angle you go at, and that happens to be the angle that would get you 4 units going this way and 8 units going this way to make the pyramid, so to speak. So that has to be your lighthouse effect, would be the 45-degree angle. Now what he's doing in the GIF is just making up a new angle, alright, that gets him to the beam splitter, even though the mirror won't be here, so there's no mirror here. okay, at this new angle, and but that does get him to the beam splitter. And then he's pointing out how the other thing isn't lined up. Well, of course it's not lined up, because you change this angle, which changes where this will be in any moment of time. So for this to hit the beam splitter, yes, of course it would be here. And so we're just back to that line. The only place it's going to be on the line is at the proper angle. So what's your excuse for this angle? Where did this angle come from? You just made it up to get it to hit, for one of them to hit. But like I said, you could make it any angle, and you could just do the angle where this ball hits, and you'd see that they're not going to line up. Yes, of course not, because the only one where this ends on the line is this angle, the 45-degree angle. So anyway, the point is that these, I guess I'll just say it one more time, okay? They all have to line up. The mirror, the beam splitter, and the observer are all on the same motion. They're all going this way. So you can just kind of understand that if I move them forward, and I'm here, that clearly there's no way, if I hit it, I'm not going to be in line. If I change the angle, I can force something to happen. So if it hits here and I change this angle of this mirror, then I can force a new angle, but this mirror moved while this distance happened. So that won't work. So the angle has to be one that gets me going this way, but the problem with that is then this line doesn't work. So I'm just saying it always breaks. You know, it always breaks. You won't be receiving the light half the time. You won't be able to receive both beams. There's no way you can do it. Alright. Because the one beam can't do both things. It can't hit this mirror at the right, and get here, because that requires it to be at instantaneous speed. Because as soon as it hits this mirror, this thing's moving. And this thing's not going to be in the straight line anymore, because both of those move this way, and you can't get down and in. You can hit the surface, but you won't be going the right, you won't end up in the right place. Well, that's not entirely true. So you got to be really careful. So you hit the mirror, you hit this, and then this is now at this new position here. So, okay, so I have to concede you always have to add the distances. So you can get this alignment, but you'll never get that alignment unless this angle. So the key thing to ask the guy who made the GIF is, you just made up this angle, right? You don't care that it's not a 45-degree angle, representing half the speed of light. So it's just another one of the cheats. But anyway, I don't know how to establish a point beyond what I've already stated, that I don't think there's any evidence that photons move in this future direction. And if they could move in this future direction, you think there has to be a rule about which angle they move in that future direction, and that would dictate your scenario, where what I've stated is that then at least the two photons would be on the same plane at the same time and be received at the same time by the receiver, if the receiver could be in two locations at once, which it can't. So you can't receive both beams. Alright, so this really has to be just analyzed at slow speeds. In slow speeds, you can use angles of this mirror to cheat the location and force a view. And that's sort of indicated in Michelson-Morley that their problem was, as they rotated the device, they lost their alignment. So that sort of demonstrates that fact, that as you rotate it, you're going to change the speed angles that are obviously this moving forward thing changes as you're not moving the speed of light in this direction anymore, and that means that this angle has to change for you to actually go through the beam splitter and hopefully hit the eye. Alright. Short of doing my own animation, which again I don't even know how to do it, because I can make concessions. I can say it's okay to have an angle, and then I could say it's okay to, let's just pretend that the mirror is continuous, and so I'll allow you to not have to hit the mirror. You know, but how many concessions do I make? It's, you know, it's no point. Alright, so I guess I'm just going to argue what I think happens. And so what I think happens is the photons miss the mirror. And they can hit the mirror at slow speeds, but they'll hit the mirror at different locations. And that you have to change the angle of the mirror will allow you to force it to hit some portion of the beam splitter at a different angle and be received as a signal. But any changing of the position will change that angle, and the alignment of the beams will no longer be in alignment. Even if you have them at least out of phase, but in alignment. But any rotation will take them out of alignment. Okay, whatever. I don't know if it's so again, I'll just emphasize, why are you allowed to make this angle anything when this angle has to be proportional to your speed in this direction? So I asked the GIF guy that question. Why is he allowed to conveniently okay, create angles that aren't that angle, that aren't proportional to speed? And if he says Lorentz transformation, well then again, we're, we might as well give Michelson-Morley the Nobel Prize. Einstein didn't get it for general relativity. Maybe that's why he didn't get it for the relativity arguments. It's because Michelson-Morley invented that, something like that. Yeah, so I guess I'll do the other video as a separate video, because they're separate subjects. Is there anything else I need to? I don't think there's any point in beating the dead horse, but we'll see see if he has a point. Previous drawing, some kind. Anyway, till next time.